Hello, and welcome to the Tentative Tutor channel. Here's an interesting one. Find all positive integers n for which n times 2 to the n plus 1 is a perfect square. Do you know how to do this one? Leave your answer in the comments. If you'd like to pause the video and think about it, I'll solve this problem in 3, 2, 1. Let's first try some values. For n equal to 1 times 2 to the 1 plus 1 is 3, and that's not a perfect square. How about n equal to 2? 2 times 2 squared plus 1 is 9, and that works. That's a perfect square. What about 3? We see that that also works, as 25 is a perfect square. However, 4 doesn't work, as 4 times 2 to the 4th plus 1 is 65, and that is not a perfect square. So far we have n equal to 2 and n equal to 3. Are there any others? First, we need a minor result, which I'm calling the little lemma. For any integer n greater than or equal to 6, n is less than 2 to the n minus 3. We could prove this by induction, but just look at n equal to 6, 7, and so forth. We see that it's true for n equal to 6, and as you add 1 on the left and double on the right side is always much bigger than the left. Now let's look at what happens when n is greater than or equal to 5. Suppose there is an x for which our expression is equal to x squared, where x is some positive integer. Let's subtract 1 from both sides, and we can see that x squared minus 1 factors as it's the difference of two squares. Notice that x plus 1 and x minus 1 are both even, and their greatest common divisor is 2. Can you show that either 2n minus 1 divides x plus 1, or it divides x minus 1? Here's a hint. Can 4 divide both numbers? If it divides x plus 1, then x plus 1 would have to be greater than or equal to 2 to the n minus 1. And if it divides x minus 1, then x minus 1 would have to be greater than or equal to 2 to the n minus 1. So one or the other must be true. But in either case, we're always going to have that x plus 1 is greater than or equal to 2 to the n minus 1. Now let's plug that into the above expression. If x plus 1 is greater than or equal to 2 to the n minus 1, x minus 1 must be greater than or equal to 2 to the n minus 1 minus 2. After all, they differ by 2. So we get the expression on the right. So this is the inequality we end up with. Let's simplify it a little bit. We'll add 2 to the n to both sides, and then we'll divide both sides by 2 to the n. On the left, we end up with n plus 1 being greater than or equal to 2 to the n minus 2. But for n greater than or equal to 5, this violates our lemma. So this is a contradiction. So there are no solutions greater than or equal to 5. So n equal to 2 and n equal to 3 must be the only positive integers for which our expression is a perfect square. And that's our answer. Now here's our bonus problem. Find all positive integers n for which 2 to the n plus 1 is a perfect square. Give it a try and leave your answer in the comments. Once again, thanks for watching.